welcome to another live coding session as part of our Frivolous Gravitas Extras mini-series. You are greeted by myself, Kristopher Driver, and today's episode is brought to you by the Frivolous Gravitas podcast, my podcast co-hosted and co-produced by Jordan Roy. So if you like fun, free educational content, like long-form discussions, things like that, just check out the channel where we host long-form discussions on subjects of substance. So, as always, I'll post my files with the comments on GitHub, and I'll leave links in the description for all of that. But enough of the inglorious self-promotion already, let's get straight to it. So in our past videos, we covered functions, data types, objects, arrays, booleans, strings, numbers, that kind of thing, including some recursion, which we started off with in the first episode. We talked about loops and classes, and we even played a bit with methods, which are just functions that are attached to primitive data objects to create templates for our data. So today we're going to cover some multi-threaded processing, and that's just to say JavaScript in the browser running on more than one CPU core or logical processor core. First, though, I guess we need to explain threads and events to help things make a bit more sense as we go along. But before any of that even, we just need to make sure you know what the document object model is, because that's what I'll be referring to. So you don't really have to memorize it or know the granular details of how it's implemented or how it works, but just a general sense of what it is when I refer to the DOM, the document object model. That'll help you create a sense of key concepts and terminologies and jargon as I go along. So the DOM is just like a data tree. When you look at HTML, you can see tags that are nested inside of other tags. The body is beside the head tag, so they're like siblings, but both the head tag and the body tag are nested under the HTML tags. So the parent of the head, the parent is the head and the body, for example. But you could imagine if you had like if you had images or something like that and you package them into containers like divisions on pages, div tags, you can move them around the page. So div tags are often nested inside of other div tags. And that's just what we mean by siblings, being that they're beside each other on the document object model tree, the DOM tree, or their parent, which is what they're nested inside of. It's a hierarchy one level higher. And their children would be any div tags or images or whatever that are nested inside of the smaller, or not the smaller, but the tags that are marked up underneath their parents. So you've got child, sibling, parents. So JavaScript can manipulate the DOM by setting a selector. And we've done things like this before using the getElementsById and getElementsByTagName methods earlier in the video, so I'll show you those again too. But just like I always grab the body tag right at the beginning of my scripts, because you usually wind up using it at some point, so I usually just start there. Don't have to, obviously, you can always just call it when you need it. But other than that, we changed the style property of some elements that we selected using that getElementsByTagName or getElementById. And we use the document object to call those methods. So the document object is part of the window object, and the window object is basically just the entire frame of the browser that we're working in. It's the lexical scope or the relative scope. It's essentially the same thing as the DOM tree, but the DOM tree is just the data that tells the browser how to publish or how to present or render. These are all just synonyms basically for the purposes of our video. They're synonymous. So yeah, we did that using style. The style property is part of the CSS or cascading style sheets, and that's just a way to take elements that you display in HTML and then style them or decorate them to make them look a bit different. So adding like borders or positioning them or anything like that. But we'll probably do a video on style sheets eventually. I'm avoiding it because it's boring. But actually, maybe we will get into it actually today, because one of the only things that is fun about CSS is its ability to do animations, and it renders animations really well after. I guess we're on version 3 of CSS now, so browsers have built-in functions to make use of hardware acceleration, so animations are actually nice and smooth and easy to do in CSS now. But that's pretty much it for the DOM. It's just the thing we look at, but the document object model in the background is the thing that the JavaScript and the web page and the browser and everything manipulate and move things around in, so that you can see something visual react when you do use code that changes the way elements are displayed on the page. So in JavaScript then, we have the event loop. And we did work a little bit with events before, but essentially what the event loop is just that the sequence of JavaScript, its interpreter and compiler, it checks for events in sort of a sequential list. Because it's single-threaded, and we'll get into threading in just a minute, but because it's only got one thread, one order of code execution from top to bottom, excluding details like hoisting, like we talked about, how functions are called up and brought to the front, but minor implementation detail. The event loop is something that just checks for actions by the user that maybe we want to respond to. So most of the time it'll do absolutely nothing and skip through most of them because there are like 100 different events and we only use a couple of them, like key press, mouse move, mouse over, when an element or an object is loaded. So there's like an onload event. We used events for timers too. When we did the set timeout and set interval. Maybe we'll, if there's a reason to, I'll probably use it in a worker thread actually to artificially slow it down just so we can see what the concurrent threads are doing. But so an event is anything like a window resize or a button click or anything like that. It's just an action when we want to have triggered to run a function. So you can think of like in school when there's a teacher and a whole bunch of kids. And the kids want to ask a question, they lift up their hand. It's sort of like raising a flag, like, hey, I've got something to say. That's what an event does. And because JavaScript is single-threaded, it has to run through a loop over and over again and keep checking if there's an event that's fired, because that's what event listeners do. They're sort of listening for an action so that they know that there's going to be something to do when that action is called. So the reason you need an event loop, that is because there's only a single thread in JavaScript, and what we're going to do today is concurrent multi-threading, or using web workers, in other words, to run scripts off the main thread, so that if we have a code and it has to sit there and wait for like a response, say from a server, if we do a fetch request from another URL, from another website or anything like that, or if we have data that we want to manipulate or strings that we want to change up or anything like that that might take some more time, and we don't want to block the main thread because otherwise the page will be non-responsive until that piece of code finishes if you block the main thread. So you want to move that work off onto another thread so that the main page can keep loading, and then it'll just listen and wait to hear back from this other worker thread. And when it hears back, it'll fire a function, and we'll just pass in a function to that event listener. So that's what gets called when the event is triggered. And that's how we'll be passing data back and forth and sort of communicating with our other thread from our main thread. So JavaScript is, I guess to put it another way, it's sort of like it only does one bit of code at a time. But I say sort of because the compiler does do a lot of background changes to make it more efficient and optimize your code so that it runs fast. JavaScript used to be known for being really, really slow, but over the years and the engine iterations, as we talked about in prior episodes, those engines have gotten extremely fast. And a lot of that comes down to branch prediction and like better browsers. Chrome and Firefox now actually have pretty comparable JavaScript engines, but they're not identical. They are very specifically different, but only in edge cases. So because of this, though, because we're not using single-threaded JavaScript, unlike our past videos when we did everything from one single HTML page and just put all of our scripts inside of a script tag, we're still going to need that script tag, and I'll try and keep it as simple as possible. But to make to make multi-core processing actually run in a web browser, you do need a separate file for it to open, because the data can't be exchanged between the main thread and the worker thread, simply because if the worker starts operating on a variable that you need on your main thread, you'll get conflicts and race conditions where one script is running faster than the other or slower than the other, and it could change the data before it's used or called. And that's not the behavior you really want, right? You want expected behavior that repeats itself every time, not something that'll change depending on how quickly one script runs over another script, right? So that's why when you write a loop that accidentally loops infinitely, the whole browser locks up. It's because JavaScript is inherently single-threaded, but we've added the functionality over the years of being able to do multi-core processing just by having another thread working from another file separately and then just communicating back and forth like sending messages. So over the years, some clever engineers have designed a way to build multiprocessing API on top of JavaScript so that we can offload some code that might need more time to run. But usually that's stuff that we don't need immediately. So lots of times this will be something like loading images into cache, that fast temporary local storage for web assets, like images that might be bigger or take longer to download. And that's just to improve the user experience and loading times. It's not really a functionality thing. It's more like a user experience thing. But you can also use it to manipulate large strings of data or databases or tables of data or anything like that that might take more time. If you've got to iterate through lists of thousands of entries in a database, probably best not to block your main thread with it. Just have it run in the background, and when it's done, it can just kick all that information back to your main thread, and you can change the DOM as you need it, as it's done. But that's one of the limitations to worker threads, is that we're not allowed to change the DOM from a worker thread. So it's sort of like a sub-process or a subroutine to the main thread. It's, well, the old terminology was master-slave, but I guess that's probably not kosher comments these days. But you'd essentially have that type of relationship where one controls all of the other. That way you don't have those race conditions or what do you call it? Or have memory leakages or variables being overwritten that you didn't want them to, or race conditions and that kind of thing. But it's also for security reasons. You don't really want scripts to be able to do whatever they want in the background. They should have to report to somewhere centralized and have that script as your main script. There's probably hacky ways around it, but we're not going to get into that today. Just so you know, there's a lot of flexibility and variability with the JavaScript language. And you can really contort things like we talked about before with prototypes and data objects. You can do whatever you want with JavaScript if you're willing to put in the time and effort to figure out how the back end works. But for now, JavaScript allows us to do our multiprocessing or using several cores in a few different ways. So the original hack was to have a web page open a new tab, which automatically spawns a new thread to work on, and that's just built into the browser functionality, which is really, really handy, and we sort of used that before we had the web workers to just spawn off other web pages and have them communicate back and forth through like get and post messages through HTML and HTTP requests. But there's an easier way to do it now. We can run JavaScript on a server, but I don't mean like a server that's like far away, or I mean you can do it on there, that's what it's meant for, but just locally when you're developing for your own projects and stuff. You can set up a mock server, basically. And that mock server is going to communicate with the code that we're writing here as if it was being processed on a separate server, but it's just being run locally, but it runs through network protocols locally. So even if you're not connected to a network, when you set up a live server to do code or web scripting or this type of thing, it's pretending as if it's communicating with a server that's remote. And that gives us the functionality that we need to be able to branch off processes and have them run in the background. But because our computer is going to be mocking the server, it's going to be our computer that shows the threads being used while they're running. But to do this, we need to change up a couple things that we did for our standard. So I'm just going to keep some boilerplate code up, something that we've seen from all of our other pages, from our other videos, just to get started so you don't have to sit and watch me type. But one thing that's different that you'll have to note is our script tag. We're going to be changing the type from text/JavaScript, which we've been doing in all of our other videos. We're going to be changing that to module. And module is specifically required for this type of processing because it's going to be requesting information through the server and communicating with the server. And original JavaScript, just plain vanilla JavaScript from back in the day, was just client side. All the processing was done on the computer that was running it. And most computers only had one core back then, and that's why it was so slow, because it had to wait for the event loop and it had to do everything sequentially and in order. But if you want to run asynchronous code, there are a couple ways of doing it. One is the web workers, which I'll show you today, and another way is just setting up async functions, which I think I showed you briefly in a past video, but I'm not exactly sure. But we can do a separate video just on async, because that returns an object called a promise, and promises are probably enough for a whole video anyway. But to follow along with this episode, I recommend using VS Code. It's a free programming text editor. It is from Microsoft, but it is very good. It works well, has tons of integrations and customizations, and it's easy to use. Mostly why I'd recommend it though for this video, instead of using just generic text editors like I've been doing before, like Sublime Text or whatever, is that there's an extension that you can just add on to it. Maybe I'll show you that quick. Boop, boop. There we go. So if you go into VS Code, under the bar here, and if you don't see the bar on the side, it's just Control B to open up the bar. This live server extension here, you just quickly open it and install it. And using that, we're going to be able to just right click anywhere in the background here and spin up a live server. Oop, if I could get it to work. There we go. Open live server, and you'll see it pops up my address, but it gives me an address for my router and throws it onto an open port for us. And that's how we're going to be running all our code. So I might as well just do our Control-Shift-I like we always do to open up the console. And the first time I load, for some reason it always gives you a 404, but you just hit refresh and the error goes away. But the nice thing about this is whenever I save over here, I'm just going to keep this, I'm going to keep this on top so it doesn't go away when I click over here. So yeah, this is just Chrome, regular browser, nothing fancy, nothing special. But let me get rid of this. There we go. But the nice thing about this is when I hit Control S over here, it's going to save. And then my window here with my browser and my console is going to refresh automatically. So instead of having to Control Tab into my browser and then hit reload every time I make a save a change to see the updates or the changes, it's just going to do it live and easier. And it's going to make coding with you guys a lot quicker. So before we start that, oops. Sorry, having some fun with OBS Studio here. So that's one of those things, the flexibilities that makes JavaScript such an amazing tool, is it can be repurposed from web development to serve other functions, just like playing with libraries of tools that others have developed or released for free. You'll need to download and install Node.js for this to work too. That's the other caveat. There are a bunch of other videos and tutorials and stuff on YouTube that will explain it a lot better than me, and they'll walk through the actual installation, which only takes a couple minutes. But essentially, you could even do it from inside the VS Code development environment. If you hit Control tilde, which is just underneath the escape key, you can open up what that does is it pops up a terminal, and then you can just enter the commands from the tutorial videos that you're watching online, and it'll install from there, and you can just, you're up and running in a couple minutes, so I won't get into it. But after you've installed Node.js, that's just a JavaScript sort of repository for a whole bunch of other packages and stuff you can download that other developers have created. And they're excellent free tools for not just web development, but if you want to chart some data or something like that, you can use chart.js. And if you want to run really neat animations or physics-based animations, you can run, what is it called? Springs, React Springs.js, something like that. There's like animation libraries and image processing libraries and yada, yada, yada. So why do we want to have multiple threads? Well, we talked before about not trying to block the main thread because then the user experience is affected. But for our purposes, we're going to be using them because we can process data on all of our cores. And most computers now have more than, well, at least 4 cores, but most of them now have 4 cores and 8 threads when you see hardware for CPUs being advertised. The number of cores it's not that it makes the computer faster, but it makes your experience of the computer faster because you're able to do stuff concurrently as opposed to sequentially. You can do stuff on the side and have it sitting there waiting, ready to be plucked from your main thread, while instead of having everything lock up and hold and wait till it's done and then finish executing code, then lock up and hold and wait till it's done and finish executing code. So for things like machine learning, you can also do in JavaScript. Web workers, I think, is how they implement their multiprocessing, but I'm not entirely sure. I haven't dealt too much with TensorFlow in JavaScript yet, but I will be soon. So stay tuned and stay subscribed for that upcoming tutorials. In order to run scripts that take time, and in order to do so without blocking the main thread, we fork one main thread into 2 or 5 or 7 or whatever we want to do. I call it, well, I guess the actual word for it is you're bifurcating a single thread. You're taking one thread and splitting it off into 2. But another way of referring to it would be like subprocesses, or if you're familiar with Visual Basic or Excel VB script, I think they call it subroutines in there, but it's all essentially the same thing. And it's just sending work off from one thread to another and passing the data that the worker needs, and then the worker just sends a message back, and we just need to set up an event listener that says, hey, this worker is going to be sending us a message when it's done, so just be on the lookout for it. And as the event loop runs, 100 times per second in the JavaScript engine of our main file, it will just be listening out for, like the teacher analogy, it'll be looking around to see if any kids got their hands up before they keep going. And that's sort of the event loop in a nutshell. So there are limitations to web workers, which I'll only cover briefly, but you can always check the documentation for more information. And if I get stumped, I might even have to refer to it in this tutorial, because I haven't used them very often, but like I said, I'm doing these tutorials to help practice. And with that practice, I'm intending to do multi-core processing and machine learning through the browser for some of my lighter, more optimized machine learning AI models. But if you're inclined, you can always see what's under the hood by checking the documentation. That's the nice thing about open source stuff. But web workers don't have access to the DOM or DOM elements, that document object model tree. So when we write our markup in HTML and we say, hey, we want to put a picture here, we want to put a text field here, we want to put a button over here, that type of stuff can be sent to a web worker as information so that it can use it to see like what the label is of something. But it can't change it or affect any updates. What it can do is send data back to the original main thread, and then the main thread can choose to use that data and update the document model. That's fine. But you can't update it directly from the worker, because then you'll get conflicts with memory and the rendering and stuff like that. So it's just important to note that there are some limitations to worker threads, because it is kind of a hacky workaround for a sequentially written, interpreted, but kind of compiled language like JavaScript. It sort of sits in the middle of all these different definitions in the programming sphere. But that's what makes it so useful, and that's why I love it. It's quirky. So the second limitation is that unlike multi-threading in operating systems or games or productivity applications like Photoshop, we don't have any access to I/O signals, input-output. So interactivity with the user, basically. If you had a remote control or a game controller or mouse events and stuff like that, you have to use the main thread to capture the mouse event and send that data into the worker thread, then wait for it to come back. and then process it. So if you're going to be doing any type of, like, if you want to write a game in JavaScript, you can absolutely do that, but keep all of your controls and stuff on the main thread so that the user experience isn't affected by a web worker waiting to get listened to from an event listener, because it can't receive those output on its own. But it can do things like HTTP requests, which they always take a few seconds to like resolve an address, download the information from the website, parse it back, and then send it. So if you did that on the main thread, you'd just be sitting there waiting at one line of code for the data to come back, and it might not be something that you need right away, but it's still going to block the thread. So you might want to move that off onto a worker, knowing that at the end of your script, you're going to need that information. And then after you've processed your entire page, then it can sit there and wait for a response if it's still not done. But usually it'll be done before then anyway. So we're going to butcher our workers though, just so that we can see that it's actually concurrently processing and it's not just running off of one thread. But that'll just be for the demonstration purposes, not for practical uses. So other than that, like numerical operations, sorting arrays, or like merging tables of data or filtering, things like that might take time. We'll kick those off onto a worker thread, but we'll keep everything else onto our main thread. So that's pretty much the precursor to today's feature presentation. Let's just get started in coding. I'll try and make this video a little bit shorter than the last ones. So hopefully you can see. I'll try and keep this up for you too. And good to go. So as always, we've just got our HTML page. It's saved as .htm. I'm going to do a live and a pre-notated one, just like I did last time. I think that worked out pretty well. And I'll throw all the links to the files and description down below. So today is concurrency multi-threading, and these are our head tags, body tag, and I guess I should normally we'd indent these, but just to save screen space, I'm not going to. You can tell the difference, like the head tag opens and starts here, and it's inside of the HTML tag. HTML tag closes, body tag opens, script is inside of the body tag. So that's what we're talking about with like nested elements. Anything between these angle brackets is just, it's an HTML element. So, where should we get started? I guess I'll just start by making a worker. To do this, we need a separate file for a worker, so I'm just going to go in here and create a file, and I'm going to call it worker1.js. .js is just a JavaScript file. And I'm going to have to create a worker. So again, this part is really important. I don't think it works if you don't put type module there, which is why I put this comment just to remind me to mention it to you guys. So I'm going to need a worker. So I'm going to say const side worker equals new worker. And then inside this is a pre-built class, the worker. That's the extension sort of that we're going to be using and needing from module. It's just built in, but you have to give it a file to work from. Otherwise, if you put your code in here direct, it's basically all still running off the same thread as this page. We have to push it off onto another page so that it's or from another script or something, so that it can run concurrently on another process without blocking this thread. So that's the reason I'm putting this in. And again, if you moved your file somewhere else, the / means the current directory and then whatever's in it. So that's the directory that our HTML file is in. So a lot of people have like a JS folder or a scripts folder, just so you don't have all your files plugging up in one directory and it gets all messy. But for the sake of this presentation, I'm just going to use one worker and I'll just reuse it over and over again. But just keep in mind, you can have a whole bunch of different scripts too. Maybe we will get into, I'll just run a loop or something later and make a whole bunch of them. But anyway, I'm getting ahead of myself. So with that worker, I'm going to need to create an event listener, like I mentioned before, and this event listener needs this. Remember, there's some parts of programming that you have to memorize, and others that you just have to understand how the blocks of parameters and arguments and stuff go inside of methods. So this is a method that's built into the document object, and a document object is, I believe it's essentially the same thing as saying window dot, but actually let's just do a console log and make sure that everything's running before we get too far, because common pitfall. Oh, right. I didn't finish writing my event listener, so it threw an error. So you'll see when I do a console log, it gives me my body tag, and it gives me all the child elements inside of my body tag, which is exactly what I want. So that's up and running. I've created my new worker, and I'm going to pass it 2 arguments. One of the things you have to memorize, which I was trying to say, is the event that you're looking for in a worker specifically is message. So an event that you were looking for say like an image, might be click. For a canvas element where you've got animations rendering or something, it might be on mouse over or mouse move or mouse down or something like that. Those are all types of events. Window resize, that's an event. You can find out the list of events just by console logging a window or any element you're looking at and just see what's attached to it in its prototypes, because most of those methods will be labeled with the word on, so like on mouse down, on key down, that kind of thing. Just a mental note that that's how you can play with some new event listeners. But the other argument that you have to pass it is going to be a function, and this is just like we talked about. Well, I'm not even going to get into it. Arrow functions. We've done a bunch of these before. So arrow functions, and it gives us an event that gets triggered. It gives us an event object so that we can actually draw things like if you want the mouse coordinates on mouse move, you can get them from this event. And this variable can be anything that you want. That's what you're going to be using inside of the function that gets called when the event listener gets fired. So usually I just call it E, but just to switch things up, to remind ourselves, make a mental note that we can change this to whatever we want, but to use it, we just have to use it exactly how it's written up here. So just to see that that's working, I can do console log event, but I have to write something in my web worker here. So basically what I'm saying is this side worker, I'm creating it, new worker, I'm creating it from this file, so it's going to run this script. That's what the worker does. And then I'm adding an event to it to say that when that worker sends a message, when it sends an event, and then my event loop goes through and then finally catches up and says, oh, I got a message from one of my workers, fire this script. And this script is going to have attached to it the work that is sent, or the message that's sent from the web worker itself. Excuse me. From the worker itself. And that's how you're going to be able to take something that was processed in another file, bring it into this file, and then start using it after it's been processed, so you don't have to wait for it to process on our main thread. That means that we're going to go into our worker here and sorry, I'm having some OBS Studio issues again. So this I'm just going to attach to the main object. This is just a JS file that we created. Here, let me make some more room here. This is just that JS file that we created and are importing into our worker. Actually, do one better. Oops, split down. There you go. So these are 2 separate files here. This is just calling our web worker. And inside worker1.js, that's this here, we're going to add another event listener that looks for a message, because that's the default, that's the event that it's looking for to communicate with another web worker is the word message, the string message. So if you mistype this, your entire thing's not going to work. So in this case, well, we're only going to need one argument, so I don't need the brackets. And again, it's going to take a message and an event function, or an event passed into a function. And that's going to be the information that's sent from here. So when I put in message and send a function, that's for when it receives something back. But to send information to the worker and tell it to do something, I'm going to call post message. That's the name. So dot post message, and I'm going to give it a message in there to process. Now, what message should I give it? Well, for now, I'll just say this is a message from our main thread. So this is what I'm going to be sending to the web worker and telling it to process. And then inside of my web worker script here, it's going to say listen for a message from our main thread, and then it's going to give us an event. That event is the message that's being posted. So this post message is our event, and inside e.data is where our message is going to be held. So just to make sure everything's up and running and working, let's say console log our e.data, and what we're expecting to get back is this string of text here is our data. So that's the message that was posted in. But again, it doesn't have to be a message. It can be an object with like table values or field values or something like that we want to actually process and do some programming on, so that our thread does something and it doesn't just sit open and return something back right away. But just to make sure it's all working, set this up and save it, set this up and save it, and you'll see in our console, I don't know if you can see that, hold on, I'll make it bigger. So you can see inside the console, this is our message from our main thread, but it's being called and run from worker1.js. And the reason for that is the event that's triggered, this message here, gives us an event object, which is the post message that we give it. And this is our event object. And inside of E, the standard is data. So it's a property inside of the E object, the event object that we're receiving from the post message method. And we're just console logging out whatever message we get. So again, if I change this to, or I don't even need to change it, I can just post another one. I can give it just a regular object and just say key one is message one. And this is just any regular object that I'm, key value pairs. Just showing you that you can throw anything into this post message and that's what it's going to give you. Message 2. So now you'll see the console log up here, e.data, is actually giving us an object, and the object has keys and data in it, just like we were working with before in our arrays and methods video. So you can see already how this would be really powerful, because you can transfer data back and forth between your main thread and your worker thread. But one of the neatest things about this is that you can run a whole bunch of processes all at the same time. To do that, maybe I'll have to write a script first that actually bogs down our system a little bit. So let's make a worker pool. And I'm just going to make an array that's just a pool of a bunch of different web workers so that we can spin them all out and see how they run. So let worker pool equal an array, and we got nothing in the array yet, but we're going to make a for loop to let I equal 0. Let's say num to run. This way we can easily change how many times or how many workers we're creating. I'm just gonna set like a default value on here, 5 for now, and that way I can just change it up here without having to change it in the code later. But it's the same thing as just writing 5 in here for now. So while I is less than 5, have it increment. And then what do you want to do in the loop? So inside of our loop, I want to make worker pool my array that I just created, and I want to push something onto it. What do I want to push onto it? A new worker. And just like we did up there, I got to give it the file name for our worker. So I will just show you the dot notation there. Again, this is just for paths. Current path and then the file inside the current path is the same thing as just doing this without just calling it by name. And with JS files, .js, I think you can do it even without the file extension, because I think it's assumed in JavaScript, but I'm not going to play around with that too much because live coding leads to trouble and lengthy videos. So I created our worker pool, and I'm going to push. So for every time that we run through this loop from 0 to 5, I'm going to create a new worker and throw it into my worker pool array just by pushing it on top. But for each one of my workers, my worker pool, and I'm going to use index of I, because remember, every time this runs through, it's going to be using I to do its count to see whether or not it needs to loop again. And because I'm working with an empty array, I know that 0 is the first element in the array when I push on a new element to it. So I can just say the worker index I, and that'll be whichever worker I just created after pushing on top here. I'm going to need to add an event listener, just like I did to event listener, just like we did up here, where I had to add a message event and then pass in a function for it to call when the event responds back, or when the worker responds back, I mean. So same as before, I'm just going to add a message, and in here I'm just going to throw in another arrow function. And from our arrow function, let's just do like we did before and console log our data. So e.data and e. So remember, scopes, this e does not affect any of the other e's, as every time this runs through, this is just a temporary variable to store the action that we're going to take when this web worker is called here. Maybe I'll do some separation too, just to make it a little bit easier to see. So like, and then when I save it, you'll notice that this auto-populates and updates, which is nice. So all we've done is created the workers, but we haven't posted any messages to them. So that's why it hasn't done anything yet. So now we can just take our worker pool, now that we've got them all created, and we can just run a for each, which is a method that you can run on any array. And that takes in, not sure which of these I'll need yet, so I'll just add them all and I can take them out later. It's easier than going back and forth. So post message is the method that we want to use, and I want to send it just a message to see if the workers are running. So worker number, and then I. Now remember, this I is not the same as this I, except technically it is. Or I mean, technically it's not, but basically it is. Because when we're running this loop and we're starting from 0 and we're counting up to 5, we're using this as the index for our array. So at the same token, when I use the for each method, it gives me in order, value, index, and the array that I'm working on in case you need it. So I'm going to say the current value of this iteration, because remember this loops through every element in the array. So the current value of the current element is one of our workers that we created. And the message I'm going to pass to it is worker number, which is a static text, but then I'm going to give it I, the index of the current value that's being cycled through. And what that's going to do is going to send it over to our web worker up here. And our web worker's got a listener that just says, hey, when I get a message, console log out the event data. And data is, again, just pre-prescribed the property that you're going to use to get the information out of the method that called it, or the thing that triggered the event for the worker, in other words. So yeah, that should run, and I don't need to save that one because nothing's changed on it. So you'll see here, this kind of moved in and out of order, and that's because we're running this on a separate thread. So whenever it finishes, it's got to wait for the main thread to ask for the information from that event. It's not going to automatically trigger as soon as it's done and ready. It says, I'm done and ready, it lifts up its hand, and then the browser or the main thread has to go through its event loop and check all of its other things, like did you make a click, did you make a key down, did, all those browser rendering things that we change. And then when it finally gets to it, which it does like 100 times a second, as I said, I mean, the goal is to just get 60 frames per second. So, but I guess it needs about 8 milliseconds to paint, so instead of 16 milliseconds or 20 milliseconds, you've got about 16, something like that, before it starts looking janky or twitchy on your browser. But, yeah, we don't need to worry about that just yet. What was I saying? Oh yeah, so that's why these are coming in out of order, is because that's just the order that the event loop is processing it in. And every time you save and reset, it'll sort of jump around because it just depends on how fast the worker responds, how fast the browser responds, and I've got live server running, so it's gonna change up our latency every now and then. But you can tell that because they go out of order all the time, that it's definitely working as a multi-threaded process. Single-threaded process, it would not do that. It would constantly be in the same sequence every time you run it, unless you did something like a set timeout. But like I said, that's a built-in function that sort of sends work off to the browser instead of a script. So it sort of does the same thing when you run set interval or set timeout, and then call a function from that. But it's not as flexible or usable as doing this, because this way you can actually do work. Like you can have it call information from another website and wait for a response from a data server or something like that. Whereas a set timeout doesn't do that. Set timeout is just a timer that sits and waits. That's why they can build it into the browser, because it's really, really simple and straightforward. There's not much to it. So maybe I'll start working with some dates and objects and stuff. So I'm gonna get into our web worker a little bit and give it something to do so that it takes a bit longer, and then we can try and time it maybe. Well, maybe I'll do that from the main thread first, and then I'll work with the service workers after, because we want to make sure it works before we start bogging down the CPU on something that's just going to crash. So let's just start with a demo function then. And I'm going to want a start time variable, and I'll show you a couple new objects and methods. So date.now is just one way of getting the current time. I think it gives it a number to you in milliseconds. Let's just check that. Milliseconds starting from like January 1st of 1970 or something like that. UTC time in computers is weird because I think it's a Unix thing actually from back in the day, but anyway, getting too far into it. The way they calculate time is just basically from a baseline date that everybody's agreed upon, and that's January 1st, 1970. There's probably a reason for that. But it just gives you the time in milliseconds, and then if you want to convert that to like just the day and month, or just the time without the seconds, or whatever, you can convert it from there, but it just gives you the most specific number first, and then after that, you can do what you want to make it display a little bit different. So date.now is weird, because usually you want to create a date object, a normal date object, so like object. Normally you do it like this and say new date, but date.now is just a quick way to get the system date immediately without having to create a data object or anything like that for it. So I'll probably use, I might as well. I'll use both, but date time is probably its own video just because it's complicated. There's a lot of built-in methods, and they're all very useful because you can like shift months or time zones or do those types of calculations, which are an absolute nightmare if you're trying to code from hand. So that's why they're built in. But I'm just going to create some random numbers to make our computer work. And I'm going to put that to a string and just start manipulating a string a bit. How do I want to do this? So I'm going to take that string and I'm going to split it into an array, and I should console log that too, just so you guys can see what we're looking at. Rand. So math.random is going to give me a floating point between 0 and 1, and I'm just going to convert that entire thing into a string, and then I'm going to split it into an array that is just every character has its own element in the array, and then I'm going to console log it, and we'll just see if that's running. And to make that run, I just got to run demo. So you'll see concurrency live HTM, that's the file I'm working with here, that's our main thread. This number is the current time. So every time I update that, you'll notice that the number updates. That's from our date.now. I console logged that just to make sure it was working, because I do mess that up sometimes. Here is our random number converted into strings, and you'll notice that we always get a 0 and a dot before it. So I'm going to run, again, not the best script, just a long script. I'm going to do this the hard way to just make the process take a little bit longer so that I can time the start and ending of our script, and we'll see how long it took each one of our threads to run the same amount of code, and they should be different if I give it enough work to do. So I need like an output variable, I guess, and that'll just be empty for now, and then ran.forEach, just like we did before with our for each loop. Value index array. Arrow function is the same as saying function and then a name and then open close parentheses, open close curly braces. This is just the shorthand way of doing it. It's the newer way of doing it too. So most people you'll see moving forward, if you're learning JavaScript, this is going to be the more common syntax, because it's easier to read once you get used to looking at it. So I'm going to write a script. I basically just want to take out, because I'm not really getting a random number if my first character is always 0. That's not very random. So I'm going to take out the 0, and then the point, the period, I can't really do anything with that either. So I'm going to take that out. But normally you just hit splice 0 and then 2 characters as the 2 parameters. So 0 is the starting index, and then the second parameter is how many characters would you like to remove from 0, or how many elements would you like to remove from 0. So if you put just 0, 2, it would remove both the 0 and the dot, and all you'd be left with is the rest of this, all these string elements in the array. But I want to do it a longer way just to make the computer take longer to process them. So I'm going to say if the value equals dot, which is a string of a dot, not just the dot itself, then I want to console log the value of, no, that doesn't make sense. V is the value that we remove from our array. Something like that. And then if it is that one, I'm going to do the splice method like I said. Starting at index 0, just remove 1 character. Again, the faster way to do it would just be to put a 2 here, but you wouldn't need this if statement and all that if you were just doing the 2, because they're all the same. I could just put that splice up here. Well, I'll just show you. ran.splice 0, 2. This would do the same as below, but it will run too quick. So I'm just going to comment that out, but just so you know, what I'm doing here is not a pattern that you should be repeating in the wild or in practice. It's just for the sake of making our processors take longer so that we have something to look at. And the else is going to be output num plus equals v. So what I'm doing here is I'm making a string called output, and there's nothing in it. I'm going to say output plus equals v, meaning as long as it's not a dot, I'm going to take the value of the current iteration from a random number. So the first time it'll be 0, the second time it'll be dot, the second time after that it'll be 8, 4, 2, blah, blah, blah. And that's being created just from a random number, and I'm currying another method to it. So the output of math.random is going to be converted to a string, and then I'm splitting it into an array. just to help you follow. So remember, when we concatenating strings is different from adding numbers and stuff together. So even though it's numbers I'm working with here, it's wrapped in quotation marks, and that means it's treated as text. It's the text value of 4. So when I add 4 to 1 and they're both text values, the output value would be a string of 4, 1, because you're concatenating, not doing the mathematical addition. So when I say output plus equals value, it means this is the shorthand for saying output equals output plus whatever I put after it. So that would be the same as saying output equals output, so itself plus v. And v is just going to be the current value of whatever index it's at, and the index that it's at is just one of these strings of numbers, and then I'll parse them afterwards. Yeah, so that should be good for that. And that's going to give me an output. So I should be able to just console log our output here just to make sure that we're not getting any errors already. Oh, we do have an error. Uncaught. Output num is not defined. Oh, I just called it output. That's why. Output num. Reference error. Output is not defined. There we go. And output num. Gotta keep them consistent. So on line 40, way up here, we just created a random number, split it into an array, and we're getting text of each element, each digit of that random value. Here it says dot is the value that we removed from our array, and then you'll see that when we print it out, the result from our if statement here, the dot was removed. And we also want to remove the 0, So I guess I can put another one in here. Actually, I'll do it up here. Practice some else ifs. So if this time I'm going to use the index. So if the index equals 0, so if it's the first index in our array, that's the one that we're going to want to, yeah, we're also going to want to remove that one. So ran.splice. Sorry, I'm just thinking to make sure that it doesn't trip up down here. So when the first one cuts out, that'll be index of 0, and then it removes it. So index of 0 is going to be the period, but we're saying if value equals periods, it doesn't matter what the index is, just remove, well, we'll do it down here too. Remove the current index and then remove one element from it. So we're doing the exact same thing as up here, but notice this inline is the same as, yeah, you guys know that because we've been doing a lot of this, but that's the same. I'm just going to keep it all on one line because it's really simple and straightforward. Excuse me, really simple and straightforward, and I guess since I got that, I don't really need these. And I'll clean up our code down here too, just to give us some more room. That should still run. See, when I save, it automatically reloads my page here because I've got live server running, which is super handy. Okay, so console output line 52 is what I'm looking for. That's this one here. And what we're getting is without the without the leading 0 and the leading dot, we've got our random number, and that should change every time I save and update. Cool. And again, this is not the quick pattern or the best pattern, this is just a pattern. We're doing this to intentionally slow down our processor to make it do some work. But first I want to mark the time. Yeah, I should just make a new variable for that. So that's our demo function all in here, up in here. So I'm going to make some new variables just so we can set some timers. I think new date requires, we'll see. Time.toDate string. So toDateString is just a method that's attached to any date object that you create, and this is just the same as we did with classes, but again, it's a built-in, so it's special and different, but it comes with a whole bunch of methods that you can use to check things, like getting the date in a milliseconds since January 1st of 1970 isn't a very helpful number to finding out what day it is today or what time it is right now. So I'm going to convert it into a string, and then I'll fire off a console log so you can see what it looks like. So time, and then time string. So line 57 is time. So from our new datetime object, it just gives us absolutely all the information you need to know what time it is specifically right now. I'm in Central Standard Time. And then toString, this is just a text string. So this is what the type of method you would usually use if you're posting it on a website or something like that, because people want to read regular time. They don't want to read all of this to see what time it is. If you just want to have a little component at the corner of the screen that shows your users what you're doing. So I want to make this take some time now. Well, yeah, I'll do it on a single thread, and then I'll show you a single thread working too hard, and then we'll throw it onto other threads. So I'm just going to parse in our output first, because I want to put that into a number that I can work with later if I want. I'll just call this Z because I don't know what to call it yet. I'm just going to make an empty array, just like I did before, and I'm going to make a loop that creates a whole bunch of random numbers and does some math to them, just to make the processor do a whole bunch of runs to slow it down. So let time to run equal. Well, we'll start with 10 just in case I screw something up. If I run it like a million times, you can make it crash. So you sort of have to find a balance between when I'm trying to intentionally slow down the browser processing our codes just for demonstration purposes, and I get a start and end time, and then compare the difference between the two to see how long it took to run. But if I put in like 20 million or 200 million or something like that, the browser will just think it's caught in an infinite loop, and it'll try and crash to save you from a permalock, from permanently locking the system up. I'll use n just to help remind you that you can use anything you want in here. And so while n is smaller than time to run, times to run. Then n++, because we want to increment the n so that we don't get stuck in an infinite loop. And just the standard for loop like we did before. I'm just going to use one-letter variables just because it's not really important what we're doing in here. All that's important is that we're making the processor work, essentially. So y is going to equal, actually, I'll do this a quicker way. So y, z, and then I just want to push the result onto our array that we put here. So that z, it's just empty now, but I'm going to do a little bit of math on my, what do you call it? On my variables in here, my math.randoms. Sorry, trying to talk and type again. And this isn't anything specific. I'm just doing something randomly. Like, I don't want it to be too hard on the CPU, like I said, just because it'll crash my browser, but I do want it to do enough work that it'll slow everything down just a little bit. And I guess I also need an end time. So equals same thing we did before, date.now. Notice I'm doing it a little bit different. Last time I used the new date, which creates a new date object and assigns it to the variable time. But date.now is just using the built-in, kind of like math.random is just using a built-in, where it just spits out the answer right away. It doesn't create an object and store it and hold it for you, whereas this time object is going to stay there until I change its value or delete it or something like that. So just keep in mind what you're doing and what's going on in the background while you're writing your code, because it makes sense to pay attention to the More so the structure than the actual syntax or the look of your code, because you can always refactor working code after. Just get it working, and then once you get it working, you can fix things afterwards, right? But knowing the difference between a class object or just an output value from a built-in is kind of important conceptually, just to wrap your head around so you know what the computer's doing in the background. So to find out how long things run, I'm just going to get the difference from the start to the finish. I'm going to use some long variable names this time just to help me not get confused, because when I talk and type, I start forgetting what my simple x, y, z variables that are poorly named, like these ones up here, the ones you should never do. I'm not going to remember what they're for. But if you use descriptive names is always best. And I'm going to create an output object. I'm just using a literal like we've done before, and that way we can see the information that we're actually processing and creating, see some type of output. So difference, start and end time. And you notice VS Code, the IDE, like we were talking about before, the integrated development environment, it gives you clues and hints so you don't have to type out long words even if you use them. So there's really no excuse not to use descriptive variable names just to help you read through the code. But yeah, I mean, it's obviously best to use good names, but sometimes you'll sit there and you'll spend time thinking about the best name you can use, and it blocks you. So when you're first starting to write a script, you might just put anything in there so you don't lose your train of thought, and then you can go back and change it afterwards to make it more descriptive later. The IDEs help with that a lot too. So I'm going to need to console log out some of my results, otherwise there won't be anything to look at. Oh, I caught an error already. ParseInt is not defined. That's because I misspelled it. Where is parseInt? Line 60. There it is. Part C. ParseInt. Output num is not defined. Why do I keep putting this? Output num. See, it's not within the global scope, so I don't have access to it outside of this function. But as soon as I move output num outside of the function can use it, but then I can also use it down here. So that's the reason it was returning this output num is not defined at line 60. It's because it was defined, but it was defined inside of the scope of a function that I wasn't writing code in. Just food for thought. Reference W is not defined. Line 68. Oh, I didn't use W. X, Y. There you go. Z.push is not a function. It should be. Z.push is not a function. But why not? I defined it here as a variable. As an array, I mean. I'm just going to write a quick testing to see why that's not working. Oh, it's because I'm redefining it down here. That's the problem. So this is part of the practice. So even when you know how to do something, actually physically writing it down will give you the opportunity to screw it up. And that's the practice. So because I was defining it up here, and then trying to define it again down here, it was giving me a lexical scope for this. So this is what I meant to do. I meant to call this W, and that's why I wrote W down here. W. so that I could use z.push onto my array from up here inside of my loop. So now start time is not defined. I thought I called start time up here. Again, I threw it in my demo. So bringing that outside of the scope of the demo should give me access to it further down here. So line 53 is this guy here. It's output num from demo. Demo I'm calling down here. That's when it's running. My worker threads, which is good. This is the message from our main thread, and then our object was here, but I didn't get a line 82 for some reason. Oh yes, I did. It's up here. So it sort of gets even harder to debug too as things go on, because now you don't have that sequential order of your console logs. They're just going to get logged whenever they get fired. So you got to keep in mind that you'll have to look from the top to the bottom, whereas before we used to be able to just look at them in order, but as you'll see, they come in any order they get processed. So it's just random. So I created this array with a whole bunch of random numbers in it, did some math to it, and I should have time taken is 0, so I need to give it some more times to run. Let's try 1,000. Oh, still 0. That's too easy. So let's try 9,900 or 100,000. Oh, there you go. So now time taken, I finally get a number out here that takes 8 milliseconds to process this. And what did I do? I made 10. Yeah, I made 100,000. This is just an array, but they're breaking it down because I have so many indexes. But this is an array with 100,000 elements to it, and they're all just random numbers. And I made the computer generate all the random numbers, and then I made it do a bunch of math on them. So it didn't just like push them out and try and optimize it. It actually pushed out the numbers, but then it had to do something to them, and that has a tendency to slow things down. And that was the whole point of writing this script, because it doesn't actually do anything useful. But what it does do is this time taken is the difference between our end time and the start time from up here. I just did end time minus start time. That's the difference, and the difference in this case is only 8 milliseconds. Let's see if we can really push it. Give it 200,000. Yeah, so instead of 8, now this time it took 12, but every time I refresh it should be slightly different. See, there's 11 milliseconds and 9 milliseconds that time. So yeah, now that I've got that working, let's throw that into some worker threads. And oh no, actually first I'm going to slow this down some more and pop up with Control tilde. I just give you my console here. And inside the console, I'm just gonna hit H-top, and that's going to give me my CPU cores and stuff. So I'll move this over here for now. And when I hit save, you'll notice I've got a bunch of cores running just because I'm recording a video and stuff too. But when I hit save, from here, you should be able to see one thread just spike up. Maybe I need to... Let's see here. Let's try 1. Oh, my computer's still too fast. I'm trying to slow it down without crashing it though. So how many am I doing here? 5 million. Let's try 7 million. I'm looking for one of these bars to spike up really high when it's under load. Oh, I think I saw it there. Let's try that again. It's kind of hard to see. there you go. So you got one bar that spiked up there when I refreshed it because I ran it 1.7 million times. That's how long it took to, or how many runs we had to do to make it actually struggle a little bit. Well, noticeably. I mean, it'd be easier to notice if I wasn't using a bunch of my cores to record a video and run a live server and all that, but you get the idea. One of them spikes up when I run this code because I'm only running it on the main thread, but if I dump this code into one of my workers, I should be able to get my workers to have the same type of latency. So let me just scroll this down here. Now what I'm going to do is tell it, when this worker receives a post message from my main thread, I want to tell it to do something, right? And I want it to slow everything down so that I can see all my cores working to make sure that we're doing our concurrent processing, because we already know that this one works. And we know that we can make a whole bunch of web workers. We can make a pool of them just by running a loop, and I can change this number to create more workers so that we can see a whole pool of workers running in the background. But they're all going to run off the same script, but again, you could use any other script that you want. So you could have one that does image loading, another one that does fetch requests, or you could have one individual one for every fetch request you do, however you want to organize your code. But I'm just going to run a whole bunch of the same script, but each script is going to be different because I'm going to be using random numbers and that timestamp thing that we did, the timestamp pattern that we did in the main thread. I'm going to do it in the workers now, and we'll see how much time we can get it to take. Oh, I've already got console log up here. Boom. So what do I need then? Actually, I can just copy and paste most of that code. So here I've got I copy and pasted the code that we wrote down there, essentially. I just used the plus equals this time, but it's the same thing. We're using our slow code to just show our web workers running in the background. I just want to make sure I do this without everything crashing. That's the only reason I'm a little bit tentative and hesitant here. But let's start the same way we did before. I'll just create an empty array. Time to run. This time I'll say 1 million. What is that? 1, 2, 3. Yeah. 1 million. And I'm going to have to make another for loop. And for that, I'm just going to say let n equal 0, while n is less than time to run n plus plus. And then inside that loop, I want to create just a couple variables of random numbers, and I'm going to do a little bit of math on them again just to make the computer work a little bit harder. Otherwise, it'll be finished too quick, and we won't be able to tell the difference between it running concurrently and between it running just a regular thread. I'm having typing issues. So x times y, and did I parse int? Gotta make sure I parse int before. No, because that'll return an integer anyway, so I don't have to worry about that here. I don't think. We'll see. It'll give me an error. It'll let me know if I'm wrong. No need to get it right on the first go. So date.now, and what else do I need? Difference in time. So let difference equal end time minus start time. And then I'm going to create an output object so that I can send that output object over to my main thread and have my main thread console log out the data that it gets from the event, which is the message event. Remember when we add the event listener to all of our workers, and then that's when they raise their hand and say, hey, I'm done, I've got data for you, here you go. You pull it out by getting the whatever variable you set. I use the variable E or EVT for event. It's that dot data. It's the data property of the object that it returns. That's what we're going to be using. And the reason it does that automatically, it's not just magic or anything like that. It's when we initialized it as a worker, that's just how the worker functions. So learning libraries and inputs and things like that, usually you'll import a library at the top and then you'll use a class structure like this, and it'll tell you what it expects to receive and what it spits out. And then based on that's why it's important to actually know what data types are, is because knowing what a data type is means that you can know right off the hop what you can and can't do with all these functions when you look them up on, say, W3 schools or something like that. Like here I have, just regular events, right? Here's an event, and here's some JavaScript code that they give you as an example. You can just look things up through Google search or through w3schools.com is a good resource, mdn.com, whatever. They'll give you a list of events, and you can just play with any event, knowing what type of instruction you're supposed to put in. So knowing that a string of text gets matched up to the event type, like on click, or just click in this case, because on click is anyway, that's the JavaScript shorthand for it. Instead of adding an event listener, you can just do dot on click. But in this case, message is what the worker class expects to receive. Message is the string that you use to associate the event so that the event listener knows what it's listening for. So this type of structure is going to be consistent every time you make an event listener. You're going to say, okay, there's a string that I need, not just a word or a variable or something. Well, it can be a variable, but just to know what it expects, that this has to match something that's in their list of prescribed event handlers, is what they call them. Well, the function is what's called the handler because it handles the event that you pass in. But this new worker, it needs this message string to know what it's listening for, because that's just how it's pre-programmed, hard-coded in, right? And then they tell you, hey, this is how you use it. You just need to enter a string that says message, and then you can toss whatever you want into it. That's just for the lister. But for the actual message itself, you can pass in object and data, like I was saying before. So let's change this out. Let's actually make a data object. And with that, I'm going to make, I'm going to give it all the variables that we pushed onto our Z array. So this is just pushing in one value that's X times Y. And again, that's just to make it do some math on the random numbers we got. So I'm going to give it rands, so output obj.rands.rands. That's what I'm putting here, is the property of our output object, and it's just going to spit back the array that's attached to these random numbers that we generated here. And remember, this is our web worker. This is our worker script. So when I spin up 10 or 50 or 100 of these, or 1,000 of them if I want, they're all going to have different numbers because they're all going to be using random numbers and then multiply them together. So our data object or output object should be different every time. And because of that processing in the background, they should take different amounts of time, but close to about the same amount of time, if that makes any sense. So I'll make a time taken object then that is just the difference that we computed above, and random outputs is, what did I call that? Output num? Yeah, output num. Just so we have something to spit back. And then all I have to do is post a message, just like I did on the other end when I was sending information to my web worker. Now I'm in my web worker, I want to send information back to my main thread. I'm going to post message the output object I created here, and then save. Whoa, look at it go. So just to, I guess I'll recap a little bit. What we did is we collected a start time here. I guess I don't really need that, so I'll comment it out. I took the random number that we generated, spun it out into a string, and then took that string and I split it out into an array, and every index of that array is just its own because this is empty in quotations. And again, single quotes or double quotes, you can use either, but you can't mix them. So if you start opening a double quote, you have to close it with a double quote. If you open with a single quote, you have to close it with a single quote. But they both do the same thing. It's just so you can use apostrophes and stuff in there. But anyway, so then I'm going to create an output number. That's just a number I want to give myself at the end. Just it's something for the computer to do to show that it's doing something. If it's a dot, it's going to cycle through all of our indexes. And remember, we're creating a string from a floating point. So the floating point always starts with 0 dot, and then our random number is something between 0 and 1. So all of those digits in between are all random, but the first digit is always a 0, so it's not random. And then the dot isn't even a number, it's just a dot. So we're going to remove the dot in a long, stupid way. Remember, we could have done this much quicker if we just spliced out the first two, starting at index 0. Remove 2 elements from this array. So that's the splice method on any array. That's how you remove elements from an array. I don't need to console log this because I'm going to run this worker and then output this object here. And rands is anything I wanted to call it. It's just a property of output object. I'm giving it Z, which is an array that we've pushed onto all the values of our math.randoms here. And I'm going to give us the time difference, which is the end time minus the start time. So I got end time, date.now, and start time was date.now up there. And that's just going to tell us how long it took the script from start to finish, because this part is what's going to be making it take so long, because I'm making it run 1,000,000 times. Not hyperbolic, that's like literally 1,000,000. And then once it's done, because it can't give me this object until it's done doing all of this processing, right? Once it's finally done everything and it's taken its time, it'll send a message back out to the main script and say, hey, I'm done, I've got some data for you. And our main script has these event listeners on them where it says, hey, when you get post message from one of your workers, and remember each worker has its own event listener attached to it because I created it inside of a loop, and inside of that loop I said whatever this current element is, it's a new worker, and whatever that new worker is, attach an event listener to it. So it's specific, that one worker's message is specific to this this created web worker inside of our worker pool. So a worker pool is an array that's just storing all of our different web workers inside of it. And the handy thing about that is, because it's an array, I can loop through each of them using just a for each method, for example. There's many other ways you could do it. You could use filter or map or some of the other stuff that we covered in prior videos. But I'm going to post a message to it this time saying worker number is blah. And that's how we got all of, I guess I removed the console log of it, but I'll just add it in here quick. Worker pool. So you notice way at the top here, I've got my worker pool, and because I've got a loop going from 0 to 5, while I is less than 5, create a new worker, and each one of these workers is posting, but it's not giving me the data I wanted. So I have an error somewhere. I just gotta find it now. Oh, it's because it wasn't processed yet, so of course. So as the script is running, it's sent off to all the workers saying, hey, do all this. But nothing's come back yet because the worker hadn't finished working. So I just console logged it as soon as they were created, but I posted the message and didn't give them time to finish. And that's why there's no information inside of this console log here. But, I guess I can take that line out too. Where is that? Line 13 of my worker script. That's just getting in the way, making things messy. And you'll notice how long it takes too, because I'm running a million times for each one of these each one of these workers, and every time they run through, they're going to give me a different amount of time that it took them to finish that processing. And inside, you'll see each one of these objects has a huge number of just random numbers that I multiplied, divided, and squared. So they don't do anything practically useful, of course, but the interesting thing is we know that these are running off of separate threads. So what I can do with our main script is make a bunch more workers. And I'm just going to bring up the console again so that you can see my processors running. So all of these bars are just my CPU usage on my system. But in our code, instead of times to run 5, I'm going to write 15. And you should see, instead of just, when I hit save, it's just going to automatically reload here. So what you should see is while it's doing all this processing, all my cores should jump up. If I've got enough work on them, they should jump up to 100%. Whereas before, only one core was jumping up. Yeah, I don't think I have enough. There. Maybe 2 million. Like I said, I'm just trying to do this without it crashing. If I put too many in, it's just going to crash. There we go. So I've got a main thread running long, and all my other threads are all my other workers, and they actually just pool up. So if I had 150 of them, I've only got 16 threads to work with, like 8 CPU cores, but it's hyper-threaded, so every cycle I get to run 2 threads. Most modern CPUs do hyper-threading, unless you're working with Intel, because they kind of dropped the ball the last few years, but they do have hyper-threading too. But anyway, the point is we're running all of these from within our worker threads, and whereas JavaScript would normally just be single-threaded or sequentially read and written and printed out to the console, I'm creating a bunch of random numbers from within these threads, and what am I doing? 2 million per thread, and I've got, well, let's ramp this up a bit, just for effect. Let's do 32. Hopefully that won't crash. So as you can see, they're all working independently. They're all running. My processors are working hard, doing all the math. It's still spitting out here. Now the time taken, you can see that it's gone up much, much higher, because now it's cycling between a whole bunch of different threads. So the earliest ones are going to be finished first. And the ones that take longer, more or less, will be, you'll see these ones came out of order, but that's because I'm running on, 16 core CPU. But yeah, that's pretty much it. Web workers off in the distance. Concurrency in the browser, who knew? It is very simple to set up Node, especially if you follow instructions from using VS Code, because most of the tutorials you find online, or on YouTube anyway, will be on VS Code, and you can just enter the install script from straight in the terminal here, in here, and you can install it just from there, without having to download packages and then find a place to save them and then run installed and reboot your. You don't have to do any of that. You just spin it up in here, and then again, make sure you got the extension for the live server. Not all of the live servers that are available run JavaScript, so make sure you pick this one specifically by Ritwick Day if you want to make sure that you get one that actually runs JavaScript. And to launch it or to stop it, you just right click anywhere in the background, open live server, stop live server. That's pretty much all there is to that. Yeah, maybe I'll keep this one shorter than the other videos. It's already about an hour and a half, but yeah, something you can play with. Especially, like I said, if you're fetching data from like a website, or you're scraping websites to gather information, like news sites, for instance. If you had a website that you wanted current news to show up, you could scrape a website by running a script that runs in a web worker and calls like yahoo.com, and then parses the HTML that it gets back from yahoo.com. Then after it finds the URLs to the news headlines or something like that, you can have that information sent back to your main thread so that your main web page can now post live content that's posted on somebody else's. But make sure you obviously don't violate copyrights and things like that. But just as little tools for yourself, like if you wanted to make a home page or a splash page that when you turn your computer on, you have you have access to just tools that are helpful for yourself. But yeah, these are all our workers. Remember, we did a console log on them. And I guess just before we go, at the end here, I'll just do another console log on our worker pool. Worker pool. So hopefully our workers at the end will have some more useful data. Oh, I have to wait till it finishes. Can't remember how long it took last time. Go, go, go. Oh, I guess they don't show the data in there, but sort of what I was getting at was the data object that we get from our event listener. This here. That is basically being contained within each one of these workers, but these workers also have like on error, on message. They have other events that you can do too. They're probably very useful, but I haven't. I'm not so familiar with web design that I could tell you a use case for them. But if you just do a quick search in, I don't know, in W3 Schools, it should come up with web worker events or something like that. Get out of here. Oh, that's not very helpful. Maybe they call them service workers. Okay, W3 Schools sucks. Service workers, JavaScript. Oh, there you go. So developers.google.com if you want some good documentation. Oh, that's another thing we should go into, the navigator, just quickly before we go. And I'll show you, yeah, I'll do that with an async function too, just so you can see the, using type as modules allows you to, I'm going to change this back to 5 because every time I save, it's going to reload the page, and every time I reload the page, it's going to run 2 million of these. So I'll move this down to 2,000. And then it'll run way faster and it won't bog us down. So let's just go back to the top and make some room so we can see a little bit easier. So the navigator I just sort of crawled across the last couple days just as a little point of fun. Remember I was talking about like how you could change styles, the way the presentation of the web page using JavaScript properties, because CSS works as kind of like a JavaScript object notation. So a CSS style sheet is essentially, I mean, not exactly, but it's essentially a JavaScript object. I'll get into that in another video, but that means that you can change it in JavaScript with code, which is very useful and one of the biggest, most often use cases of JavaScript in web development. But I'm just gonna, actually I don't want it to be too dark. I'm just gonna change the background quickly so you can see it. Change the background. So using style and then the pre-built-in properties is just changing the style sheet, but like on the fly in through code. But I can add another type of event listener. I don't have to just use message like this. You can use other types of event listeners like click. And instead of a regular function, I'm going to pass in an asynchronous function because I'm allowed to do that because I've got modules here and I'm running live server. Hence, again, why this is automatically refreshing for me. I should take away some of these console logs because they're getting in the way. Okay. Okay, good. So I'm going to write an async function, and to do that, it's just like any other function. I can do it with an arrow, or I can write async in front of function call. But I'm going to just use arrow functions again because that's the new standard. It's the newest way of doing it. So if you're learning how to do this, then probably best to learn it the way everybody's doing it in the wild now in practice. So this await keyword is only available to us inside of asynchronous functions. And this asynchronous function is being defined here, not called. It gets called when the click event is triggered. And again, click is one of those pre-built-in events. And it's just a string that matches to another string of event types that it's familiar with. So if you don't know them, you can just do a quick Google search or something and find the search results and say like, what kind of event listeners are there or whatever. And you can get a whole list of event listeners that way. But I'm going to have an asynchronous code that checks for some devices on my computer, because I didn't know you could do this in the web browser, but apparently you have access to like USB and stuff like that. So there's a request device method that's built into HID, which is hardware interface devices, something like that, HID, which is why I never heard of it before, because it's not very descriptive, but I guess if you know it's there, then you know it's there and you know what to look for. But filters is built into the navigator, and I guess I'll just show you how I actually figured this out. So I went in here and just did a console.log navigator, I think. Let's do it up here. So I think it's attached to the window object. Might be the document object though. There we go. So I'll make this a bit bigger. See, this navigator built in has a whole bunch of, I'll make this bigger. Has a whole bunch of built-in things, and this HID is the one that I noticed the other day. Like, you'll notice there's like keyboard, so you can change the language of a person's keyboard and things like that. But inside of built-in JavaScript prototypes here, you can see all the things that it does. And I looked at it and I was like, on connect. That to me sounds like the browser can read when you plug in a device. And I was like, I didn't know you could do that. And then I check in like get devices and request devices. And so I thought to myself, request devices, navigator. And I just looked it up in Google and see what it is. And it says like here, it's a built-in that checks for media devices. You can enumerate through them, or you can get support constraints or find out. And then it gives you code examples. And I didn't want to get too much into it because it works with promises. And promises is probably enough for its own video on its own. It's just another new feature to the new JavaScript engine that helps you run asynchronous code and things like that, because it handles errors well. But yeah, so you can just get examples from the documentation, and you can apply them directly and just type them in your browser and just sort of explore the types of things that you're allowed to do. And one of those things that you're allowed to do is request a device. So I'm going to tell it, to say when I click on the background, the body of my HTML page, make this smaller. Oh yeah, there's like geolocation and all kinds of stuff like that. Like this is one of the ways, or the types of things that websites do when they say they're using tracking cookies. What they're doing is they're doing a query onto your browser, and they're asking like, hey, is there any cookies available that I can read from? And most cookies are planted there so that people can read from them, so they can track which websites you've been to just based on the cookie name or the data that's in the cookie. But instead of doing that, I'm gonna have my code check for devices, and then okay, Okay, so await navigator, devices, filter, request device. Yeah, so I should just be able to console.log devices now. And it should show me what I got available. Maybe not. This might be something to dive through in a later episode. Or maybe I'll just fix up the code and I'll get it running and I'll show you after. I can't remember exactly how it works. Like I said, I just found it the other day, but I thought it was neat. What it does, it was popping up, oh yeah, I had to click, that's why. So navigator is not defined, and that's because I spelt it wrong. Navigator. And remember, I put this in a click event, so it's not just going to run on its own, it's going to wait till I click to run on its own. You can see it actually, it asks you for permission or whatever, and you can pull anything that's plugged into your computer off of this and run it through your browser. And this is how you do things like if you got machine learning running on your workers on the side, you could have them doing webcam image processing on a separate thread so that you can still move around and browse the web page without things being all janky and stuttery. Because the processing just for the webcam is just feeding through a service worker instead of occupying the main thread, which is going to be used for all your other interactivity, like the browser windows and how the page is displayed and text and links and images and stuff like that. You can leave those on the main thread and have the machine learning algorithm or the AI generator or whatever running in the background on a separate thread. But that's how you'd connect devices to it. So if you had like a USB game controller or something, you can map keys. Here, I'll do another one. I'll just comment this out. This doesn't need to be async. I was just showing you how it worked. And I'm going to get rid of all of this. And shoot, what was I going to do? Event listener, I'm going to change to mouse over just so that you get another idea of how some of these events work. And then console log e e.client x e.client y. And just to show you some other sort of fun things that you can do with no, that's not going to work. So e.client x plus some string is the x coordinates. And then in here, I'll just write is the y coordinates. So when I mouse over, it's going to console log my mouse and x coordinates. See that? Woo. But this is extremely important because you can do this in games, and you can make games in the browser and anybody can do it. And if you want to know what your event handler can handle, you can console log the object that you put into the event listener and then just hit that drop down arrow like I did with that navigator, and you can see everything that's built into it. Oh yeah, that's what I was going to do, the keys. So on key press. Yeah, so there's like key codes, right, that are assigned to all the different keyboard keys, and if you want to know which is which, you can just make a, I'll just comment this out. You can make an event handler that just checks for key down, right, and then inside of that event, all it does is console log it out. So if I want to know what the left key is so that I can have a listener for if the left key is pressed, move your character to the left, and if the right key is pressed, move your character to the right, but I don't know what the key is, I can use the key down event and console log that out, and it should tell me, oh, keyboard event, and when I check down here, I just need to know what the code is for it. So key code is key D. What if I put A? Ooh. So keyboard event key is D. So you can do that as one way. You can match it to the key property. I could say E dot let's say another one. We'll do a console log if the key is D. So that should return a true or false if I type the D key. Oops. But I have to be over my browser. See, it gives me true because it's just checking if the letter D is equal to the property of key, and I found that out but just by hitting the keyboard event and then typing the letter D. But there's also key codes. Key codes are more accurate and specific, but they're numeric. So it's the numeric value of whatever key you press on your keyboard. So instead of key D, I could just console log e dot key code. Notice that it's code without an S, but it's capital C for code. That's that camel case we talked about before, to separate words but without using spaces. So when I save this and I go up here, that's the right arrow, left arrow, down arrow, up arrow, A, B, C, D, E, enter key, it's number 13. So you use these key codes, and that's how you'd map sort of like, if you wanted to allow the game player of your JavaScript game to remap keys, all you'd have to do is set up a variable for the key code, for the action, for the character or player or whatever that's on screen. And from there, let's do a left, actually. I'm going to see if I can move some stuff around. So 37 is left and 39 is right. I'm just going to make a comment for myself. Left arrow equals 37 and right arrow equals 39. I'm going to create a div tag inside of my body, and that's just a page division. So it can be anything you want. Most people just, or usually when you're using it, it's just a container, but typically now in web development, it's used for everything, like even buttons now, to make nicer buttons that don't just look like those gray static buttons or whatever. Most of the time, people will just use a div tag and change the div to make it look like a button. But I'm going to call it my div, and then I'm going to have to grab it from in here. So we'll use our document.get element by ID. My div is what I called it. Now I'm going to change the style to have some type of transition. Style.transition. And then that way I can show you some animation before we go. But before we do that, I can't remember CSS transition. I can't remember the order, so I always have to check these up. So it goes delay, duration, property, and timing function. I gotta write that down. So delay, duration, property, timing function. I think that's the order of it. So first you say what you want to transition, then you say the amount of time. And then you can have it with like a timing function is like you can use a cubic Bezier, so you can have it ease in and out, you can have it ease out, so it starts off quick and goes slowly, or it starts off slowly and then speeds up. That's what the timing function is. I'm just writing this in here to help me remember, because first I need to set a style on my div to give it some positioning and stuff so we know what we're looking at. So my div equals dot style dot set width equals we'll just say 50 pixels, and then height equals 50 pixels. Sorry, I'll come back to here. So those are our key codes, and what I'm going to do is I'm going to set a transition on some CSS, and every time I hit that key, there's going to be an event that listens to say, hey, is this key press? Yes. If it's the right one, I'm going to move it to the right, and if it's the left one, I'm going to move it to the left. That's sort of what I'm thinking anyway. We'll see if I can get it to work in the next 5 minutes. So style position, I need an absolute positioning, otherwise it's not going to move the way I want it to. And I'm gonna start it off by telling it to start from left, say 25 pixels. My div.style.top equals 25 pixels. I'm gonna give it a background so I can see it. Again, this isn't the quickest way of doing it. I'm just showing you how to practice with JavaScript, and this is just style sheets. So this is something I guess we can cover in more detail in another episode, but just for now to give you some type of thing to play with. I'm gonna get a border, 1 pixel, solid, red. I'll give it a style, background. I'll give it an RGBA, and again, the reason why these are strings is because I'm passing this into CSS properties, and CSS properties are sort of separate, but JavaScript's allowed to grab them and manipulate them, just like HTML is sort of separate, but I can use a variable to grab an HTML element and then change it as much as I want. So in here, I'm just going to put any color, but I want to give it an opacity like 7.5, just so it looks a little bit groovy. And now, what am I doing? Okay, I'm adding an event listener to my div, so add event listener. That's going to be key, what did I call that before? Oh, I already deleted it. I'm trying to challenge myself. Key code. No, key down. That's what it was. So key down is the event. E is my event object, and then actually I should attach this to the body, because otherwise the event would only be triggered when that element is active, and having just the element active is going to be hard if the box is only 50 pixels by 50 pixels to have to keep focus on it while you're hitting the key in order for it to register the event, if you know what I mean. So in my body text, I'm going to say if e.key code, e.key code equals, shoot, I already forgot what number. Oh, there we go. 37 is for the left. 39 is to go right. So key code on the left is that. Then I'm going to say mydiv.style. We'll just change the left position. And I'm going to need a variable for this. So like tmp pos x, position x, let tmp position x. I'm just going to leave that blank. Actually, I should set that up here. So what I'm going to do is, sorry, let me just indent all this. So what I'm going to do is set it up here as just 25. And when I enter it in here, instead of just putting a full thing of text, I'm going to put in my variable, concat my variable into a string by adding a string to the end of it. So this is just a number I can do math on, but adding this turns the whole thing into a string, and the style sheet needs a string. So in here I'm going to say tmp pos x plus px to convert it back to a string, but every time I hit this key code I want to have tmp pos x change its value. But I want to change it enough that I can see it. So I'm going to, I don't want that to be a string, I want it to be a number. So I'm going to keep updating this number. The first time I hit the left key, oh, I guess I'm doing this backwards. Okay, let's do it this way. Left key, just so I don't forget what I'm doing. Right key. So when I hit the right key, I want to move the TMP position, but then I want to change the style sheet and update it. And the way I'm going to do this is to make an animation, is to add that transition property where I wrote down what I needed. So first is delay. I don't want to delay. No, first is what I'm changing. So that would be transform, I think. Yeah, because a translate is moving something side to side like this in Euclidean space, like Euclidean geometry. Transform is like scaling it, making it bigger, skewing it. A rotation is also a transform. So translate, and yeah, let's do translate instead of just left. Or no, I can do transition all. That'll be easier. So then no matter what style sheet property changes, it's going to apply the same transition to all of them. Now I have to tell it how long I want it to take. And hold on. I can't remember the order again. I'm going to double check. Oh, you can use words too. Instead of actually putting in like a matrix for your Bezier curve, you can give it some pre-built-ins, which are just ease in, ease out, ease in, out. That's what I'm looking for. So there's a shorthand transition that just basically does all of these instead of doing them one at a time. Where is it? Up here. Yeah, instead of doing all of these one at a time and saying transition delay equals this, transition duration equals this, transition property equals this, you can just do the shorthand transition like this. So what they're saying is they have two different transitions, width and height. I'm going to transform all things, all of the things, 2 seconds, and I'll do ease in, out. So this is the format I wanted. So just what you're transitioning, how long you're transitioning for it, and I think the fourth one is delay. But we'll see. Playing with stuff is always more fun than memorizing it. So ease in, out, and I'll give it a half-second delay just for fun, just for kicks. Oops, syntax error, line 33. Right, I didn't finish this. So I'm just going to say if the other one's pressed, just console log it, because I want to test that left key arrow was pressed. Because I'm going to focus on the right key here first. So 34 is missing something after an arguments list. That's that. So here I have my handy dandy div tag. Maybe I'll make this an actual color so that, you can see it. There you go. And you'll notice even color transitions too. There you go. So when it's rendering first time on the page, it has no information of how to look, so it's just an empty dot. Oops. So it's just an empty dot. But as soon as this code runs, it changes the styles to it, and the transition tells it whatever styles change, apply this type of transition. So it takes 1 second from start to finish. It's delayed by, I don't really want the delay because it's just annoying. And if we want to slow it down, say 3 seconds. Now when I push the right key, there you go. You'll notice that it's changing the style. And it's animating as we told it to do in here. I guess I can quickly code up the left key too. But if I put in here left key, it should just console log left arrow was pressed because I didn't tell it to do anything else in here. But maybe I'll do that as a challenge for you guys because I'm pretty sure I gave you enough info that you can figure this out from here. But yeah, fun things you can do with JavaScript. And if I hit it 3 or 4 times, it's going to keep going. But yeah, that's that. Thanks for watching. Like, share, and subscribe.